Hi, I'm Adolph Oliver, and this lesson deals with word problems that require more than one step to solve. They're still easy enough, however, that you can do these in your head. But as we said earlier, resist doing that. You want to practice the individual steps needed to solve these because it won't be long before we run into word problems that are more difficult, and definitely the algebra has to be used. Let's look at some beginning simple examples here, some one-liners that will translate. They're not unlike some of the single-step things we did earlier. And then we'll get to more difficult ones as we go through some of the homework examples. Here's a one-liner. 7 fewer than 8 times a number is 41. Well, remember, in one-liners like this, if we can find a word that we can replace with equals and it doesn't change the meaning, then that tells us where the equal sign goes. And that word here is the is, because if I turn around and phrase this as 7 fewer than 8 times a number equals 41, that's exactly the same thing. So in this one-liner like this, that tells me where the equal sign goes. What's to the right side is 41. Now, what's to the left side? 7 fewer than 8 times a number. Well, we want to figure out what the number is. Let's use variable n. You can use any variable you want, but n is a good one for number. 7 fewer means we are subtracting. But what is it that we are subtracting? We're subtracting the 7 here. And remember, of course, you must be careful if you're dealing with subtraction. Subtraction does not obey the commutative law, so you can't get it backwards. Whatever you're subtracting has to follow the minus sign. So here we go. Put down the minus sign, and the 7 has to go behind it. Well, what are we subtracting it from? 8 times a number, and if we're using n for our number, that's simply 8 times n, or written as 8n. So there's our equation for this beginning simple problem. Remember, of course, that one of the requirements are going to be that you give the equation. You can use a different variable, but it should be of this form. And now, to solve it, as always here in these linear equations, the first thing we want to do is think about what it is that we want to have for our final answer. And our goal, of course, is n equals whatever number the answer is. So we identify who has to move. Over on the left side, the 8n is fine. It's got n's. N's are okay. But the minus 7 doesn't have any n's, so that's what has to be moved. On the right side, the 41 is a plain number, so that can stay. So only one that's on the wrong side, this negative 7. Jump it over as positive 7. Remember, if you jump a single term, the other side of the equal sign, what it does is it changes the sign of that single term. Okay, well, the minus 7 has been reduced. We've got 8n equals over here 48. And of course, dividing both sides by 8, we easily get the answer in this problem. Our n here, of course, 48 divided by 8 is 6. So our number is 6. Well, let's look at something else down here, which is a little bit more involved in terms of how we have to handle it. It still is a one-liner. And again, we can determine a word in this one-line problem that can be replaced with equals. That's the is right here. So if we replace the is with equals, that tells me that's where the equal sign goes in the problem. So there we are. There's the equal sign. On the right side, I've got 38. There that is. But now, let's take a look and see what we have on the left here. Twice the sum of 3 and 4 times a number. Well, we want to find out what that number is, so let's say I use n again for the variable for that. But now, let's look at what's happening here. Twice means we've got to multiply somebody by 2, but who do we have to multiply by 2? We have to multiply this sum by 2. Well, sum, of course, means that we are adding together some things. And what are we summing here? Well, we're summing 3 and 4 times a number. Well, let's see. The sum of these two means we simply add them together. So I've got to take 3 and add it to 4 times a number. Well, if we're using n for our variable, that would be 4n. That would be 4 times the number right there. Well, here's the interesting thing now. We've got to force folks to take twice the sum. But of course, sum in the order of operations is one of the last things you do. It's down the bottom of the importance of everything. So how do we force folks to take this sum first and then multiply that sum by 2? Well, of course, that's what the parens exist for, the grouping symbols in the order of operations. If you put parens around the 3 plus 4n, that of course means by the order of operations that you've got to do this first. Well, they would then have to take this sum, and of course we want it to be multiplied by 2, so if we put the 2 in front here, the 2 next to the parens means to multiply what's in the parens. So here we would indeed be taking twice the sum of 3 and 4 times a number. Okay, well that took a little bit more to untangle, and we had to make use of parens, which we will in the future if we want to have things done in an order that's different from the normal order of operations. That's of course what the grouping symbols exist for, so that we can phrase things and set up equations any way we want. Okay, well now it's time to solve this, and of course one of the things to do to solve it is we've got to clear out any parens that are here. We've run into equations like that before. So use the distributive law, take this 2 in front and distribute it into both of these guys. 2 times 3 gives me 6. Then I have the plus sign. 2 times 4 gives me 8. And there's an n, so take the 2 and distribute it in here. I get 6 plus 8n, and of course the right side just equals 38. Okay, well, I've gotten rid of the parens. We know exactly how much we have of each term. We check to see if there's any collecting of like terms we can do here, but that's not the case. This is a plain number, and this is a term with the variable n. So we're all set to solve. Well, of course, now remember, the first thing we do when we're all set to solve here is we remind ourselves what we're aiming to do here. I want to have n equals whatever number the answer is. That's my final goal. So let's identify who we have to move. N's are okay on the left, so the plus 8n is okay. But the 6 out in front doesn't have any n's. It's got to move. Over on the right side, numbers are okay. 38's a plain number. So the only one that's in the wrong place here is the 6. Officially, it's a plus 6. Since we don't see a sign in front, we assume it to be positive. And now we move it over to the other side. And remember, the sign changes when you jump the other side of the fraction bar. So the plus 6 becomes negative 6. Okay, what do we end up with here? Well, 8n equals, what do we got? 38 minus 6, that's 32. And now, of course, to get our final answer, we have 8 times n. Well, let's divide both sides by 8. We do that so we get the n all by itself over here. N equals, of course, 32 divided by 8 is just 4. Okay, well now let's look at some of the types of problems we're going to have and some of the homework for this topic. And here's the first one we want to take a look at. Let's read it out here. It says 259 students went on a field trip. 5 buses were filled and 9 students traveled in cars. How many students were in each bus? Okay, well they want to figure out how many students were in each bus, so let's say B equals the number students in a bus. Okay, you could use any variable you want. Could have used S for students or your old favorite X or Y. Anyway, let's figure out how many total students. We don't know how many are in the bus, but we know that there were 5 buses. So if I take 5 times B, that's going to be the total number of students in all the buses. And there are an extra 9 students that traveled in cars, so there's an extra 9 students. So this is all the students in the buses. This is the students that were also traveling along in cars. That's got to equal the total students who made the whole trip. And they say 259 is the total number in the whole trip. Now remember, here's the power of algebra once again. At the moment, we don't know how many were in each bus, but we know this. 5 busloads full plus 9 equals 259, and having that expressed as an algebraic equation, we can now solve for what the B happens to turn out to be. Okay, well, here we go. There's no other cleanup needed to do on this. So the first thing again, let's remind ourselves what our goal is. We want to have B equals whatever number the answer turns out to be. And so this 259 number is okay on the right, the 5B is okay on the left. The only guy that's out of place is the plus 9. Okay, we move him to the other side. He changes sign, becomes minus 9. So I end up with 5B equals 250. And of course now to get what a single B is, we got to divide both sides by 5. B equals, well, let's see. 250 divided by 5 is just 50, but now this is a word problem and we've had units here. 50 what is in the bus? 50 students. So be sure that you label down what the units are. Units are required. So the things you would have given as the answer for this problem, the original equation up here, you could have used a different variable, but you would have had something of this form. And then, of course, the final answer and the units given. Don't forget, all of those things are necessary. Okay, here's another example here. Now, notice, of course, this is a lot more than just one single line, and it's not uncommon that word problems have quite a bit of information. What you've got to do is read it through and see what it is they're asking for, and then figure out how to be able to set up the equation to do it. Scott wanted to make note cards by cutting pieces of paper in half. Okay, so he's going to make note cards by cutting pieces of paper in half. Before starting, he got 3 more pieces to use. Okay, when he was done, he had 22 half pieces of paper. With how many pieces did he start? Well, let's say P here equals the number of pieces, okay, at the start. Number of pieces of paper that he had. Okay, that's of course what they want us to figure out here. And you could have used some different variable, but P is fine for pieces, even good for paper as a matter of fact. Now, before he started, he got 3 more pieces to use. So at the beginning, he had P pieces that he had prior, and then he gets 3 more. So he's got a total of P plus 3 pieces of paper. Now, he takes and makes note cards by cutting the pieces of paper in half. So each one of these pieces down here is going to make 2 note cards for him because he cuts each one of these pieces in half, which means, of course, we want to multiply the total number of pieces here by 2. Well, this is like one of those startup problems we showed you just recently. We've got to force anyone evaluating this to first calculate the total number of pieces, and then once they've got that, multiply those by 2. That'll give the total number of half pieces, or those note cards that he's making. And let's see, how many of these note cards did he end up with here? When he was done, he had 22 of those half pieces of paper. So 22 at the end. Okay, so this were the number of full sheets of paper he started with. He got 3 more. And of course, we have to force folks to add that together first, then multiply that total by 2 because each of these pieces of paper in here was cut in half, so each one gave 2 of these half note cards here, and there are 22 of those. Okay, well, let's analyze this a certain way. You'll learn different techniques to tackle a problem like this in the future, but I'm going to follow the same methods that we've been showing you so far. The first thing here is we've got to get rid of the parens. We have to know exactly how much of each we have, so we're going to use the distributive law. Take the guy in front and distribute him into each of the guys inside. Well, 2 times P is 2P. 2 times plus 3 is plus 6. So we have 2P plus 6. And of course it equals the 22 on the right. Okay, well, we've cleaned up the left side here. We've gotten rid of the parents, and now we know exactly how much of each of these terms we have. Now it's time to go ahead and start solving. So the first thing we're going to do here is, as always, remind us what our target is here. P equals whatever number the answer is. So we identify who's on the wrong side. Well, you should be getting pretty good at this by now. Remember, P's are okay in the left, numbers are okay in the right. The only guy that's on the wrong side is this +6 here. And how do we move him? Well, we jump on the other side of the equal bar, and we know that changes the sign when we do that. So, double check, +6 became -6. That's correct. We did that right. I end up with 2p on the left equals 22 minus 16. I think that's just 16. I should say 22 minus 6. That was a little slip. 22 minus 6 gives 16. And now divide both sides by 2 here so that we get what p equals all by itself. And p equals, well, 16 divided by 2 is 8. And 8 what? Well, 8 pieces of paper. That's what he had to begin with. Okay, well, you can see that this is correct if we go back and just look at this in our original equation up here. If he had 8 pieces to begin with, and he got 3 more before he started cutting them up, 8 plus 3 is 11. 2 times 11 does indeed give 22. Okay, let's look at another problem here. Not quite as many words, but still something we have to set up here. It says, how old am I if 500 reduced by 4 times my age is 144? Well, this is a one-liner, and guess what? Our favorite is shows up here. We can replace that with equals, as we've done earlier, and that tells me where the equal sign goes. So if I write the equal sign right here, then what's to the right of the is 144, so that goes to the right of the equal sign. And how old am I if 500 reduced by 4 times my age is 144? Let's say we take A equals your age. Okay, well, what we have to do on the left side, 500 reduced by 4 times my age. Well, reduced means subtract, but what are we subtracting by? 4 times my age. So this is the thing that's being subtracted. Remember, of course, whatever's being subtracted has to follow the minus sign. So here's my minus sign, 4 times my age, and we're using A for age, so that would be 4A. Okay, well, what are we subtracting it from? The 500 that's given right here. So here we are. 500 reduced by 4 times my age equals 144. Okay, we've successfully translated that into an equation. Now we have to solve it, and as always, the first step here is we're going to remind ourselves what it is here that we're aiming for. We want to solve for A equals whatever number our age happens to be. Okay, who's on the wrong side? Well, on the left side we only want A's, so the 500 is on the wrong side. The right side is a plain number, that's okay, so the only one that needs to be moved, the 500. Now, that 500, there's no sign in front, so we know that that's assumed to be positive. When we jump it over here, it comes over as -500. Okay, positive 500 became -500, so the 500 has been moved. What do we have left on the left side here? -4A. And over on this side, let's see, what are we going to have here? Take positive 144 and minus 500. Negative's going to win. And I think it's going to win by what? 356, is it? Okay, well, let's see what we get. We have to now turn around and solve for a single A. We also want to get rid of the minus sign as well as a 4 because we don't want a minus left in front of our A. So that means we're going to divide both sides by -4. Okay, over here on the left, the two 4's cancel out. The two minuses give me a plus, so I get A equals. Now notice, over here on the right, the two minuses will give me a plus, so we're going to get a positive age. That's a good thing. And let's see, 4 divided into 356. Well, 4 goes 8 times into 32, or into 50 or 35, I should say. That's 32. We end up with 3 and a 6. 4 goes into 36 9 times. So if I've done that correctly in my head, you, of course, can do it with your calculator if you want to double check that. But here we are. The age then is 89. And, of course, don't forget to indicate the units. 89 years. Okay, once again, you would need to give an equation. Here it is. And, of course, the final answer down here along with the units. Okay, here's one with a few more words, but easy to untangle. Dan had some candy to give to his 5 children. He first took 6 pieces for himself and then evenly distributed the rest among his children. Each child received 4 pieces. With how many pieces did he start? Okay, well, let's say P equals the number of starting pieces. Okay, now, let's go back and look at this once again. He first took 6 pieces for himself and then evenly distributed the rest among his 5 children. And each child then received 4 pieces. Okay, well, if P is the number of starting pieces, and he first took 6 pieces for himself, then we've got P, the number of starting pieces, minus 6. That's how many he was going to split up amongst his children. Well, he divided them evenly among them, and they said up here, in the beginning with, that he had 5 children. So, the total number of pieces that he gave out, remember he kept 6 for himself, that's why we're subtracting 6. You have to take this total number here, turn around and divide it by 5. That will be how much each of his 5 children got, and of course he says here each child received 4 pieces, so we know that the amount that each one got is 4. Okay, let's go back and take a look at how we set this up. Okay, it said that he first took 6 pieces for himself. So if we use P for the number of pieces he had to begin with, we had to reduce that by 6 to see how many he had left to spread out to his children. Well, how many total children did he have? 5 of them. So this total number of pieces had to then be divided by 5. And they tell us then that after he did all of that, each one of the children got 4 pieces, so that's why we set it equal to 4. Okay, well, let's take a look at how we can solve this guy. Here's an example now where we've got the left side being divided by 5. The easiest thing to do here is get rid of this division by 5 and turn around and just get the number of pieces equal to what it is over here. Well, let me remind you that we had a nice little trick we were using earlier on here. We'll make use of it coming up, the means and extremes method here. But for the time being, let's go ahead and what we'll do is multiply both sides by 5. Here it comes. I'll make a fraction out of this side, multiply this side by 5. Now, why am I multiplying by 5? Because I'd like to get rid of this 5 down here. And notice, of course, this is my whole numerator up here. I'll put parens around that just to indicate that that's the whole numerator. The 5 will cancel into this 5 here. That's, of course, why we did it. And so what I end up with is 1's downstairs, so the upstairs is just 1 times P minus 6, which, of course, is P minus 6. Over on this side, the denominator is 1 times 1. It's just 1, so the answer is the upstairs. 4 times 5 is 20. Okay, well, we've cleaned this up, gotten rid of this divide by 5. There are, of course, different ways you could do this, but this is one of the more straightforward ways. Now, the thing left to do here is to solve for p equals. Remember, our goal, of course, here is p equals whatever number the answer is. And, of course, the only guy that has to move here is the -6. He's the only guy on the wrong side. So I jump him over to this side. He becomes +6. And I end up with p equals 20 plus 6, or 26 of the pieces of candy. Okay, now, remember again, you need to have an original equation, kind of like this guy up here before we started working on them, and of course the final answer labeled. But let's show that this indeed works. Okay, if he had 26 pieces of candy, and he kept 6 for himself, okay, then he'd end up with 20 of them. And if he took that 20 and split it up amongst his 5 children, 20 divided by 5 does indeed equal to 4. So we can see that this answer is indeed correct. Okay, here's one where you're buying some things. Let's read what it says. You bought a magazine for $4.90 and some erasers for $3.60 each. You spent a total of $19.30. How many erasers did you buy? Well, okay, let's say E equals the number of erasers that you bought. Okay, we're letting folks know what variable we're going to use, so that's a good one to use for erasers. Now, let's write down all the stuff that was purchased. A single magazine was bought for $4.90. I'll leave the dollar signs off. We'll put it, of course, in our final answer. And then the additional cost was some erasers. Well, we don't know exactly how many, but that's why we're using the letter E to represent it. We know that each eraser costs $3.60. So if I take 3.60 times E, that will be the cost of the erasers. So here we go. Here's what we spent for the one magazine, plus what we spent for all the erasers that we got. And the one thing we know is that total amount that was spent was $19.30. So the magazine plus however many erasers at $3.60 each, total cost $19.30. Now, of course, that's going to be like the equation that you would give. Now, let's solve it. And as always here, you know, E equals whatever number the final answer is. Now, they're decimals here, but they're all 2 places. So I think it's easy enough to keep the decimals. Let's do that. The only guy that's on the wrong side is this officially plus 490 in front. So we're going to jump that over to the other side where it changes signs and becomes minus 490. Okay, well, let's see. Plus 490 became minus 490. That's correct. So I end up with 3.60 E equals, well, now let's subtract this. Let's see, if it was $5 we're subtracting, it would be $14.30, but we got to add a dime. So I think we're going to have here $14.40. Now let's double check that. Positive's going to win. 0 and 0 is 9. 4 and 9 is 13. Carry the 1. 4 and 14 is 18. And 1 is 19. Looks real good. Okay, well, the next thing I've got to do here is divide both sides by the 360. I'll have to kind of squeeze it in here. There it is. But I got to do the same thing over here. Why'd we divide by the 360? Well, I wanted to get what a single E was. So these guys reduce out. I end up down here now with E equals, and I think this goes in exactly 4 times. Let's see, 3.60 goes once, and it does indeed go 4 times in the 1440. You could, of course, get your calculator to double check this, but we end up with 4 over 1, which indicates that we've got a total of 4 of these erasers. Okay, so what happened in this problem? Well, of course, we had to give the original equation, and then the final answer here, and of course, don't forget to label what the answer is. Okay, let's see, what do we got here? Toscan won 87 pieces of gum playing hoops at the county fair. Okay, so he started out with 87 pieces of gum. At school, he gave 3 to every student in his math class. He only has 3 remaining. How many students were in his math class? Well, let's say S equals the number of students, okay, that are in his math class. So let's see what happens. We can figure out the total number of pieces. We know it's 87, but let's see how many he gave. He gave 3 to each student in his class. So if S is the number of students, then the total number he gave to all of them would be 3 times S. 3 times the total number of students in the class gives us the total number of pieces he gave to everybody in the class. Now, he ends up with just 3 remaining for himself, so he's got 3 left over. So this is the total number he gave to all of his friends in the class, plus 3 more that he has left, has to equal the total number that he started out with, which was the 87 pieces to begin with. Okay, well, there's our equation. Now, let's go ahead and solve it. And again, like I say, you're getting real used to this. Our goal, of course, is S equals whatever number the answer is. So the only one that's on the wrong side is the plus 3. We have to move that over as negative 3. Plus becomes minus, that's correct. So I end up with 3S equals, looks like 84. Okay, well, now we've got to divide both sides by 3 here to get the S all by itself. That'll tell us how many students are in the class. Let's see, 3 goes once here, and to 8 it goes twice. That's 6. There's 2 parts left over. That's 24. And 3 times 8 is 24. So I think 3 goes into 84 28 times. We end up with 28 over 1. Or S equals 28 students that were in that math class of his. Okay, once again, you'd need to give an original equation and, of course, a final answer here, complete with the units. Okay, let's see. We're talking about allowances here. Perry spent half of his weekly allowance playing mini golf. To earn more money, his parents let him mow the lawn for $8.34. What is his weekly allowance if he ended up with $17.67? Okay, well, let's say A equals what his allowance happens to be. Okay, well, then let's mimic here what he did. He spent half of his allowance playing mini golf. So whatever his A is, if we divide it by 2, that's going to give how much he spent playing mini golf. We could have also multiplied by 1/2. That would have done the same thing. Now, that's how much money he's got left after he spent half of it to play mini golf. He's still got half left. To earn more money, his parents let him mow the lawn for $8.34. So, to what he had left here, we add $8.34. And it says he ended up with $17.67. Okay, so remember, half his allowance was spent playing mini golf. That means he had the other half left. Here's the other half he had left. Plus what he earned from mowing the lawn has to equal the total amount of money he has at this moment. Okay, well, here's the whole thing set up. Now, to go ahead and solve this, again, let's remind ourselves what our goal is. A equals whatever number the answer turns out to be. Numbers are okay on the right. The terms with A's are okay on the left. The one guy that has to move that's on the wrong side is the $8.34. So we jump him over to this side. He becomes negative $8.34. Okay, well, plus became negative. That's correct. So I now have on the left side A over 2 equals, well, let's see. Let's do the subtraction here. Positive's going to win. So 7 minus 4 is 3. 6 minus 3 is 3. And 17 minus 8 is 9. So Let's double check this. 7 here, 6 here, and 17. Looks good. So a over 2 equals 9.33. Okay, well, what do we have to do to get rid of divide by 2? Simply multiply by 2. And so if we multiply both sides by 2, I can make a fraction out of this by putting a 1 underneath to remind myself that this is upstairs. The 2's cross cancel. That's exactly why we did it. A equals, and what do we end up with here? 18.66 when I turn around and multiply the 933 by 2. Well, of course, make sure we've got the units, and it's in dollars, so you have to put that dollar sign up there. There we are. So once again, you'd have to give the original equation, and of course the answer in units. Okay, well, let's look at one last problem here. And again, all of these guys, you could look at these and figure them out in your head. But again, resist doing that. Write the equations down. We need that practice, and then solve them as an equation. Okay, here we go. On Tuesday, Sharia bought 4 posters. On Wednesday, half of all the posters she had were destroyed. On Thursday, there were only 15 left. How many did she have on Monday? Well, okay, let's say P equals the number of posters, okay, that she had on Monday. Now, let's go back through and see what's happening. On Tuesday, the day after Monday, she bought 4 posters. So however many she had on Monday, she then had 4 more of them on Tuesday. So here's the amount on Monday plus the 4 on Tuesday. On Wednesday, half of all the posters she had were destroyed. So that means she lost half of these. That means, of course, that we're half left. So how many that were left? Well, half of all of these. We could divide by 2 or multiply by 1/2. It's your choice how you want to go on that. So, Wednesday, half of all the posters were destroyed. That means she's got just half of them left. On Thursday, there were only 15 left. Okay, well, that means that this total amount here has to equal just 15. Okay, let's look at this once more, see how we set it up. How many posters did she have on Monday? Okay, well, we're taking P to be that amount. On Tuesday, she bought 4 posters, so that means she had the P from Monday plus 4 more. Now, on Wednesday, half of the posters were destroyed. So if we divide that whole amount by 2, that represents half destroyed, and of course, half she still has. We'll think of this as the half she still has. And of course, how many did she have on Thursday after all this happened? She had 15. Okay, well, here's our equation, and of course, that's one of the things that we'll have to give. You could use a different variable, but you'll have something like this. Okay, now, let's take a look. Here's the whole numerator up here, P plus 4. I'll put parens around just to indicate that. It's being divided by 2. Well, one of the easiest things we could do here is get rid of this division by 2 by multiplying by 2. I'll do that to the left side, but I also will have to multiply the right side by 2. Okay, well, I can remind myself that this 2 I'm multiplying by is upstairs, because if I make a fraction out of it, the 1 goes downstairs. So these 2 guys cancel out. That's, of course, why we multiplied by 2 to neutralize out this dividing by 2. So I have left just 1 times P plus 4, or P plus 4. Well, what do I have on the right? 15 times 2. Well, that's 30. Okay, now, of course, the only thing left to do is see who we've got to move here. And let's see. Of course, we're aiming for P equals whatever number the answer happens to be. So the plus 4 is on the wrong side. It has to move over here as negative 4. And we end up with P equals 30 minus 4, or 26. of these posters. So there's our final answer, how many she had on Monday. Okay, now let's turn around and check out to make sure this works. Remember, if she had 26 posters on Monday and she bought 4 more on Tuesday, that means she had 30. On Wednesday, half of them were destroyed, so she'd only have half of the 30 left, and half of 30 is indeed 15. So we can see that that satisfies the information from the original problem. Okay, well, get to work on the homework examples for these equations here where we have more than one step to solve them.